Well, good morning, everybody. My name is Tom Isakovich. I'm the CEO and founder with Nimbus Data Systems. So today I'm going to go ahead and present the company, give you a little history on who we are, and then we'll get into some product details on what we're working on. Then we'll talk a little bit about a couple of the predictions just to kind of get the conversation going on a couple of different topics that were touched on yesterday, but I think this is a great audience to have some interesting debate on a couple ideas on where we think the future of the flash market is going. So with that, I'll go ahead and kick it off. So in a nutshell, what we do at Nimbus is we develop memory-based multi-protocol storage systems. And these systems are positioned to the I/O-intensive workloads in modern virtualization, database, cloud infrastructure, and high-performance computing applications. We call this sustainable storage. And we coined this term about 2 years ago really to focus on two areas that we think flash technology is game-changing technology for. The first is performance. How do you sustain performance in a world where CPUs and memory are getting incredibly fast, but storage hasn't kept pace? In a world where I/O is being increasingly randomized through virtualization, we believe flash technology is a key enabler of this performance, sustaining performance. And secondly, we also use this term to point to the energy aspect of our technology. We think that performance and energy efficiency go hand in hand. So part of what we're trying to do is help companies build more power efficient, more rack space efficient, leaner, meaner, greener data centers than can be done with traditional spindle-based products. So the way we view the market is, according to IDC, at around a $36–37 billion enterprise storage market. We see about a third of that going to what we'll call primary storage. And primary storage is in the use cases such as ERP, databases, email, high-end virtualization, that category. And within that category, about 95% of the products being sold in there today are based on conventional 15,000 RPM and 10,000 RPM disk drives. Now what we see happening is a very, very rapid shift to solid-state technology in that primary storage tier. In fact, I think as this pie chart here shows, is we really only believe that there are actually just two tiers of storage, either fast flash-based storage or capacity bulk SATA-based storage, or maybe even just cloud, flash and cloud potentially in the long run. But we're not big believers in having 4 or 5 different tiers of storage. This notion of tier 0, tier 1, tier 2 only being differentiated by whether one is SSD 15K or 10K, we actually see that all collapsing into one new performance tier based on flash. And the reason for that is because the cost of flash is coming down quite rapidly. And Nimbus is, I think, helping lead this charge by making flash affordable. You know, the analogy I use is that you wouldn't have first class and coach class on a plane if the cost of each seat was the same. Everyone would simply fly first class. So we think that we've brought flash technology costs down to a point where it can replace 15K and 10K today, collapse primary storage into just one new all-flash category. So just to provide a short bit of history on where we've seen the market over the past 12 or so years, I showed this slide yesterday as well, but just to reiterate here, and maybe in a little bit more detail, if we look at the year 2000 as a baseline for establishing CPU performance, memory performance, network performance, PCIe speed, and hard drive speed, you know, back in the year 2000, the processor du jour was a Pentium 4 running at 1.5 gigahertz. PCIe buses were poking along at a 32-bit, 33 megahertz interconnect. DRAM was running at DDR1 speeds, and the most prominent network technology out there was still 100 meg Ethernet. And you can see that was already when Seagate had a second generation 15,000 RPM drive. If you then fast forward to where we are here in 2012, you know, you can see CPUs today with the latest Romley technology from Intel. You have 8-core CPUs, multi-gigahertz performance. You know, they're about 30 times faster than the Pentium 4s about 12 years ago. If you look at the latest DDR that's running at 1600 megahertz, DDR3, that's about 14 times where DRAM was 12 years ago. Networks now are operating as high as 40 gigabit Ethernet, and you've got PCIe now with Gen 3 by 8 interconnects. Those slots, instead of running at 133 megabytes per second 12 years ago, they're running at 6400 today. So major performance improvements in CPU, memory, networks, and PCIe buses, but sadly drives continue to spin at the same rotational latency they did back a long time ago. So I show this not so much to point out kind of all the minutia here, but just to show how far behind drive technology really is. And this renders itself at customers in the form of them not being able to take full advantage of their latest compute and networking infrastructure, as long as they're still waiting 10 to 15 milliseconds for data from disk. Now, at the same time, power is a big challenge in today's data centers. And the way Gartner sees this is that about almost 40% of it is coming towards storage, and another 40% coming towards compute. So, our view is that the storage has become a pretty serious aspect of power consumption in the data center, and we think this needs to come down quite a bit. And as long as you've got 17 watts of drive, it's going to be pretty challenging to do so. Yeah.
Do you have any metrics or on like what's the cost point of like your power is this much? What's the payoff of running that?
It depends a little bit on kind of where you're located and how you get your power. Different countries have different power costs. I think what we're more speaking about is it's an inevitability that you're going to have a power bill, but trying to get as much out of that power bill, whatever it is. So I don't think the goal here is to really talk about here's how we're going to kind of cut a huge amount of power costs. But if your data center only has a limited amount of power coming into the building, how are you going to get as much utilization out of that data center when power becomes a limiter? If we did it on a dollars and cents basis, we'd have to probably do a different version depending on what data center you're in, what country you're in, and so on.
Consolidation.
Yeah. And a lot of customers we talk to are in a bind where they just don't have the ability to bring more power into their data centers, yet they're still dealing with 40% year-over-year storage capacity growth. They're wondering how they're going to be able to accomplish this when they can't get any more physical power into the data center. And it's too costly to, say, build another data center. So this is another...
New York on the 40th floor, you can't build another data center.
Well, exactly, and that's why we've seen this be a hot issue. Actually, particularly when we talk to government institutions that oftentimes are trying to retrofit fairly dated infrastructure. This is a big challenge, the power side of things. So anyway, that just sets up sort of the background of why Nimbus Data came to be. In the market today, we are shipping a unified solid-state storage system. We've been shipping it since 2010. So when we say unified, we're referring to the fact that it does both SAN and NAS simultaneously. So we support NFS and SMB protocols on NAS. We support iSCSI, Fiber Channel, and InfiniBand protocols on SAN. And we can do all of the above simultaneously from one box. Yes, Nigel?
What do you see from your customers as the most popular protocol or most popular interconnect?
There's no clear leader, to be honest. Today, I'd say about 30% of the customers are iSCSI, about another 30% are Fiber Channel, about another 30% are NFS, and the remainder is split between InfiniBand and SMB. And that's part of our argument that, despite all the talk of network convergence and storage convergence, that in many respects almost the exact opposite seems to be happening. Customers get entrenched on certain protocols and then continue to build their infrastructure on those protocols. The consolidation, whether it's technological or it's political, just hasn't really happened. So we think unified storage has a pretty healthy future in front of it. Add on top of this FCOE, FCOTR. Absolutely. These other protocols that emerge, and for customers that are struggling with how do they make a decision, the nice thing with Nimbus is they don't. We don't have to convince them to go to one religion or another in terms of protocol. Whatever they like, whatever their infrastructure has, we can plug into that today.
It seemed kind of unusual that somebody with NFS would want an all SSD storage system. I mean, you see 30% of your customers are using NFS?
Yeah.
Want it for VDI.
For VMware hosting.
VMware's most of it, a small portion of it as well, is Oracle Direct NFS. Because Oracle and NetApp together invested a lot into proving Oracle on NFS.
Direct NFS.
Absolutely, yeah. And with other protocols, you still got SMB 2.2, then we have SMB Direct. I mean, it's just protocol madness. There's so many. So the advantage of our solution, why we can do this, is instead of just being a box of flash, we also have compute in the box. So the system itself has a server compute engine that allows us to run file protocols and block protocols simultaneously. And that's fundamentally different than the other flash arrays on the market that are largely flash and FPGAs. and don't provide the compute engine that can run all these different protocols and all the other software services that we have. So I'll talk further about that as we go along. The other aspect of our solution that we think is very compelling is its scalability. You know, as I mentioned at the beginning, our goal is to position this technology as a replacement for traditional primary storage. If you're talking about a 10 or 20 terabyte flash box, it's going to take an awful lot of those boxes to make serious inroads into primary storage. Today's primary storage customers will be 100 terabytes, 200, maybe even 500 terabytes of capacity. And with the Nimbus technology, we're able to offer a scale solution that can scale today all the way up to 500 terabytes. And to do so in a single namespace, either as a single LUN or as a single NFS mount point or a single SMB mount point, whatever you like. And that's all part of the fact that we have an embedded file system, which I'll talk about as we go along. We're at 500 terabytes today. We believe very easily that'll go up to north of a petabyte, later this year. So there's a lot of scalability in the underlying architecture. It's also very efficient. Today, we're driving power consumption down to as little as about 5 watts per terabyte. That flash module that I was passing around earlier is about a 5-watt device. So at that power consumption, if you compare that, say, against a 600 gigabyte 15K hard drive that draws about 18 watts, we're almost double the capacity at about about a third of the power consumption. So that's how
What's the net power per gigabyte?
It depends on how large the system is. So if it's a very small configuration where the compute is a sizable portion of the overall system. So for example, our 20 terabyte box like that draws about 300 watts. So that'll be, forgive me to do the
16.
math real time. There, okay, yeah,
15.
about 15, let's say, watts per terabyte. But if you go all the way at a rack scale where the compute is a fairly small portion of the overall power consumption, we can drive it down to probably about as little as 6 or 7 watts per terabyte.
So when you scale both performance as well as capacity, or how does that work?
So it's one of the discussion points I have for later on because I think that's a pretty interesting area. The short answer is both ways. We enable customers to either scale up in a traditional dual controller product or to scale out in a node-based fashion and overlay the clustered file system of their choosing across that to aggregate those nodes together. So you'll see we have 2 products, more of a dual controller product called the EClass and then a node product called the S-Class. Okay. And then we have quite a bit of software. I'll get into the details of the software, but as I mentioned, one of the really unique value propositions of our solution is the embedded compute. So it's not just flash, but all the compute resources, and that gives us a lot of software capability that I'll talk about. In terms of the company itself, we're about 6 years old. We've been profitable since 2009, so it's a very unusual story for a startup in this space. We did not raise conventional venture capital. The company was backed by angel investors, and I'll talk about who some of those are. But ever since we became profitable in 2009, we've been growing exponentially and doing so off of our own cash flow. Last year, the company grew revenue 5-fold versus 2010. This first quarter that we just finished up, our revenue was about 4 times greater than it was in the same quarter a year ago. So we're in very much a hyper-growth mode right now. We have over 200 customers that's in production, deployed products. So not beta or QA or early adoption kind of programs, but actual in production. One of our large customers is eBay, who's well over 100 terabytes of deployed capacity. I'll talk a little bit more about them as we go along. And we've won a couple different awards, Product of the Year 3 times, and we've also been named a top 10 storage startup a few times as well. Okay. Just a little bit about the management team. So myself, I previously started another storage company that focused on SRM software, so I really enjoyed the standards debate we had yesterday because I was dealing with that face-to-face on the front lines of my last company. Before that, I was at Oracle, and before that, I was at IBM. But I've been a startup guy my whole life. My Oracle and IBM stints were fairly short, and I love building something from nothing, and it's just a ton of fun, ton of work, and a ton of fun. I really love it. We also have 3 senior people that we've added to the team that are responsible for building out the sales organization worldwide. So Jim Chumis just joined us about 6 weeks ago. He was running major accounts for NetApp. Been there for 12 years. When he left, he was responsible for about $220 million of revenue for NetApp, including running the accounts like Apple, Oracle, Yahoo, News Corp, as well as some entertainment accounts like DreamWorks and others. So he's very skilled in working these large opportunities. Before that, he was with SGI. John also joined us from NetApp. He was managing about 200 system engineers at NetApp, so he's, again, very familiar with the unified storage story. And Michel, also from NetApp, ran their Netherlands business, which was their third largest territory in Europe. He had also been with NetApp for about 12 or 13 years or so. So we've been getting a couple people out of NetApp. In terms of the advisors and investors, some of the angel investors in the company, so Ed Shao ran IBM Storage in the late 90s. Dick Watts ran the HP Unix server business in the 90s as well. Jack Russo covers our IP Intellectual Property Council. So those are some of the folks there.
Oh, I didn't know you had Ed Shao.
Yeah, yeah. Oh, you know him?
From many moons.
Many moons ago, yeah. He's had a heck of a career. He was a politician, he was in storage, he was a VC. Before he was a politician. Oh, okay. Yeah, he's got a very memorable name. Most people don't forget. He's fantastic. So, Ray, you were asking a little bit about kind of how we see this. So we actually divided the products into two camps. The E-Class product, which is a scale-up architecture, and the S-Class product, which is designed to be the foundation for a scale-out architecture. Both products actually run identical software, which is what we call our Halo operating system, and I'll get into the details of that. If you look at the E-Class, using our scale-up architecture today, we can get all the way up to 500 terabytes behind a pair of redundant controllers. We have a pretty unique architecture, what we call our distributed cache architecture, which I'll talk about on the next couple of slides. Because it's a dual controller design, it offers no single point of failure. So you can do non-disruptive code loads. You can add additional capacity on the fly while you're in production. In terms of performance, we can deliver upwards of 800,000 IOPS out of the E-Class, or about 8 gigabytes per second of uncached performance. So these numbers, by the way, uncached, no benefit of caching or DRAM. This is actually to the persistent flash memory, in and out, what the performance is.
You're not saying you don't have a RAM cache, right?
We do have a read cache.
Okay.
And so Demartech, when they ran their recent, they were able to get bursting up to around 20 gigabytes per second if they get cache hits. But we don't advertise cache hits because it's part of the problem in storage, is advertising cache hits too much.
What latency do you get, Tom?
On the E-Class, it's in the neighborhood of around 200 microseconds. The S-Class is a bit lower on the latency. It's around 100 microseconds. And I think part of that is just because in the S-Class, we integrate the controllers and the flash together in a single device, whereas in the E-Class, to get the additional capacity expansion, we have a SAS network on the back end that it adds a little bit of latency. Not much, but a little bit of latency. Okay. In terms of connectivity, as I mentioned, we support almost everything. So you have Ethernet, which will run at 40 gig, 10 gig, or gig. We have Fiber Channel, which will run at 8 gig and also downspeed to 4 gig. And we also do InfiniBand, which will run at either the FDR 56 gig speed or the QDR 40 gig speed. Customers get to choose. In fact, they can also mix and match. Both the E-Class and the S-Class have 4 I/O slots, and the customer can populate those I/O slots with a variety of different I/O cards. So they can put some Fiber Channel, some IB, some Fiber Channel, and some Ethernet, or go all one way or all another. Okay. The S-Class, similar, but not designed to scale to as much capacity, although it does scale down. The S-Class starts at 2.5 terabytes, and that 2.5 terabyte box is a $25,000 box. So we're talking with our lineup to be able to take on a fairly broad customer base. You've got the S-Class at 25K all the way up to a 500 terabyte E-Class, which will be probably about $5 million. So we can cover a pretty wide swath of customers. So we very much see this S-Class product fitting into databases, SQL Server, mid-tier VDI deployments where they tend to be pretty cost sensitive. They don't need a lot of capacity, but they do need a lot of IOPS. And at that price point and capacity point, we think it's a perfect fit. Whereas the E-Class is geared more toward large enterprise and service providers. Yes?
Is that raw capacity or net capacity?
Raw. So take about 18% off for RAID, spare, and file system capacity overhead. So yeah, about 2 terabytes 2.1 terabytes usable at the entry level.
What does live software updates mean?
That they're non-disruptive. So you can update one controller, take it offline, the system will fail over to the second controller, and then repeat the operation once the initial controller comes online. Okay. And then, of course, both products, we use eMLC flash with a 28% over provision. And we believe that large over provision allows us to do real-time garbage collection in an effective manner so that we are not impacted by any sort of write cliff phenomena which can happen with consumer SSDs that don't manage the garbage collection process well. Every one of the flash modules that we have, like this one that I was passing around earlier, has an ASIC that's doing real-time garbage collection and then managing those over-provision blocks. Now, on top of that, our file system, and I'll get into some more details about this later on, our file system is writing data in a manner that's designed to align with the page sizes of flash. So through a combination of ASICs in the flash modules and a tuned file system, we're able to get a 5-year worst-case warranty out of our product, regardless of the duty cycle. So we don't tell customers you don't have to worry about if you're writing too much, just hit it as hard as you would normally hit it. Our software also allows our customers to track NAND life and NAND durability, so they can see exactly how their NAND is doing at any given moment in terms of life left, total writes, and all that good stuff.
So Tom, are these yours SSD modules? These aren't like you're not buying these from some other company or something like that?
They're ours. And it was a decision we made when we set about doing this back in 2009 that there was a unfair cost being expected by the SSD drive guys. If you look at the it's a pretty fat margin business.
Yeah.
And at the time, STEC I think was touting kind of low 70s margins.
Yeah.
And if you think about it, it's basically a PCB assembly business, which if you're doing it at Foxconn and even at U.S. manufacturers, that's a 5 to 8% margin business on a good day.
Yeah.
And now the reason STEC, of course, had that is there wasn't a healthy market of merchant flash silicon controllers that other people could take and then combine with NAND to build their own drive. So I felt that would happen. So we made that bet. That turned out to happen. There was 7 or 8 merchant silicon controllers. And so this turned out to be a huge advantage for us. If I had to use someone else's SSD, I'd probably at least have to double my price to make to have the same cost, to make it work. Now, if the market changes over time, if 3 years from now things evolve and the SSD market's a 10% market,
I would expect the margins in that market to fall pretty dramatically.
And if they do, I'm not terribly beholden to doing this. But for now, it's a fundamental necessity if you want to be cost competitive in the market. Because at the end of the day, I'm not trying to tease out that tier 0, pay $50 a gig niche at the top end. We're basically telling customers this is next gen primary storage. So I've got to compete against a 15K disk. Yeah, but in honesty, in the long run, an SSD vendor should probably make lower margins than a hard drive vendor, because hard drive manufacturing is a fairly unique skill to do right. You have to have the specialized hardware. It's not easy to manufacture. SSD as a PCB is fairly rudimentary. So, okay. So I'd like to talk a little bit about the architecture of our product. First, I'll talk about the architecture of our scale-out product, which is the S-Class. And the architecture we use here, and I talked a little bit about this on the panel yesterday, is what we call our parallel performance architecture. And the basic premise around this architecture is that if you look at a traditional storage enclosure, a JBOD or even a RAID controller-based storage array, the way those systems reach the slot count is by using silicon known as SAS expanders on the backplane. And basically what a SAS expander does is it's a fan-out chip. So it'll take 4 lanes of SAS and fan it out into 24 lanes. And that works great in a hard drive type system, because there's no hard drive on the market today that can actually take line rate 6 gig SAS performance, so using this fan-out approach tends to work well. Customers don't really see any negatives from this in a hard drive-based solution. But now enter flash. a flash module such as our flash modules, they can easily do 540 megabytes per second. They can drive the line rate of a SAS port. So if you just stick them in that traditional enclosure that uses these expanders, what's going to happen is 24 lanes of SAS are going to funnel down to just 4 lanes of SAS. And that's going to kill your performance. So what we did in our design is we have a point-to-point architecture. Every one of the 24 slots in our enclosure has its own 6 gig dedicated SAS lane into the controllers, into the CPUs. So what that allows us to do is actually run all flash modules at line rate in parallel.
Okay, now when I get to an EClass with expansion shelves, that changes, right?
Absolutely correct. So when you go to the EClass, we have a back-end fabric which is similar to, is a SAS-based back-end fabric. But we do something else over there that sort of helps alleviate that problem. That's what we call this distributed cache architecture, which I'll talk about.
Okay.
So that's why some customers, we offer both products, because some customers are motivated by the scale-out performance that we have here. Others just like one big frame. As long as the latency is better than what they're having now, they just like having one big dual controller frame.
Well, a lot of us just don't want to worry about a controller for them.
Right, that too. So this technology, this parallel performance architecture has given us a performance leadership position. This one S-class box can do 800,000 IOPS all by itself. It can do 8 gigabytes per second of performance all by itself. And if you look at the performance claims of some of our competitors, who are based on off-the-shelf servers, you'll see there's a pretty wide gap. I kind of jumped on one of the people on the panel yesterday who was saying that it didn't really make a difference, but his product only did about 1/16 the number of IOPS per node as my product. So I think it does make a very real difference. To my knowledge, in a single system, this is a performance leading product on the market. At 8 gigabytes per second, it's better than what I've seen as the published datasheet numbers from the other players in the market for a single box. So this is what we've done with this parallel performance architecture. Now on the EClass, we utilize a different architecture altogether. As Howard pointed out, with the EClass, since we have external expansion enclosures, you can't quite get you can't apply the same architecture like we have with the S-class. But what we do here is overcome a different bottleneck in the E-class. If you look at a traditional dual controller storage system, typically you'll have a pair of heads, and those heads will be linked together over some sort of high-speed interconnect, say InfiniBand. And there will be cache mirroring between the two heads. And this sounds pretty normal. You have to do cache mirroring. But in a flash-based infrastructure, actually that caching link between the two controllers itself can become a bottleneck pretty quickly. Even if you're using, for example, an InfiniBand connection. That's only a 40 gig connection, and that is gating the performance of the entire system, because that write caching between the two controllers has to be synchronous. So the speed of that link gates the speed of the whole system. Again, maybe it wasn't an issue with HDDs, but very quickly that can become a bottleneck with a traditional, with flash. So what we do is we kind of turn everything around and say, instead of doing caching on the controller, do caching actually in the flash modules themselves. So inside each of our flash modules, we have a little bit of DRAM. The DRAM in each of these flash modules is power protected through tantalum capacitors. So you have full power protection in each of these flash modules. And you effectively distribute the write caching process across all these flash modules. Because of that, we do not need to do any cache mirroring at all between our two controllers. So the two controllers themselves have no write cache function. There's no write cache coherency function at all. And we get to eliminate that bottleneck and that complexity from our dual controller design. I have a feeling you're going to ask something, Howard.
I'm going to let you finish, because there's another way to do that I want because you could, what I started hearing about people doing is using a RAM module.
Yeah, on the back end,
right.
On the shared back end.
Right.
Yeah, this is sort of the same idea, except just instead of having 1 or 2 RAM modules, we have a little bit of RAM in every single flash module.
Right.
So the idea here was
which
to...
actually simplifies your code because you don't actually have to manage the write cache in the controllers. You just force the stuff out and let the modules take care of it.
That, and also as you add more flash, you're adding a proportional amount of cache with each flash module you add, because there's flash in every module. So
yeah, that's true of a lot of the enterprise SSDs that are widely available. Although you're not going to tell me how much RAM there is in each one, and so I can't compare them. But I understand.
But yeah, and that's sort of the idea. So with the E-Class, you don't get the parallel performance architecture, but you get this ability to add cache as you add capacity, and that helps improve performance as you add more capacity to the E-Class.
Okay. And the controller to shelf is a SAS switch architecture?
Correct. So there are, on the current E-Class, there are 6 SAS ports. So the first 6 expansion enclosures each get their own direct link into the controller. Okay. Once you go beyond 6, there's going to be a little bit of cascading.
Okay, so at best it's 24 gig per shelf.
24 gig per shelf times 6, so yeah, 144 gigs of back-end bandwidth is the max. So the E-Class will top out at around 12 gigabytes per second performance.
Yeah. Enough that...
Should be enough. So that's why we have these 2 architectures. Again, in a lot of the Web 2.0 companies, they like the scale-out approach. They simply get lots and lots of S-classes. So for example, at eBay, they've got a few dozen of these S-class devices that they're scaling out across. But at a lot of traditional enterprises, they go with the E-Class, dual controller, scale up, and it sort of slots in nicely alongside their traditional Clarion or NetApp filer type infrastructure.
It's all where in your architecture you want to put the controller failure recovery.
Right, yeah. Do you want to sort of define failure domains kind of on a node basis, or do you just want to have sort of one big failure domain but dual controller?
Right, yeah. Do you want the applications to go, couldn't talk to that controller, let me try that one? Or do you want the system to just go, controller failed, I'm not going to let you know about it? Right.
That being said, keep an eye on the S-Class, because we are working on some pretty interesting things. In the summer, we're going to be announcing something that will sort of make it even more exciting what we're doing there, so that you don't have to necessarily sacrifice HA.